a big part of what we need to learn how to do is look at a graph of a sinusoid, know how to write its equation, and then we're going to give you a value of y. And the value of y here, for this is one of the problems on your homework, says y equals 6. So they drew a horizontal line through y equals 6. And the first part of the problem says to estimate graphically the x values shown for the particular y value. So we're estimating that spot right there where the sinusoid and the horizontal line cross. And we're estimating that spot there. And we're estimating that spot. And we're estimating that spot. We're solving a problem graphically. The next thing that they ask you to do is to find the particular equation of this sinusoid. That's something that you know how to do. Now it gets a little harder. They want you to find the values numerically and find the values algebraically, and that can get pretty complicated. And this is why I'm making a video that I'm going to post on Schoology so that when you get stuck, you can go back and review this video. What you are seeing right now is an example of something that will be on your test. On the test, I'm going to show you a graph. And I'm going to tell you to draw a line at y equals a number. In this case, they drew a line at y equals 5. And if you would like to follow along in your book, this is on page 126. First, we're going to estimate graphically where they intersect. So if you look at the spot all the way to the left, it's in between a -5 and a -4. And so would you agree that -4.5 is a pretty good estimate? Yes? Okay. The next spot where they intersect is between 0 and -1. And so they said -0.5. Does that work for you? Okay. Then this next one was between 8 and 9. So they estimated it at 8.5. Make sense? Then the next one was at 12.5. And the next one was at 21.5. And the last one was at 25.5. This is something that you could have done when I first met you. If I showed you a graph and a line and I just asked you where they intersected, you could have done that, right? What you didn't know is that this was actually a sinusoid, which was an equation of a function. And so what we are going to do right now is we are going to take the equation of this sinusoid, and we have been told that the equation of this sinusoid is y equals 7 cosine 2 pi over 13 times x minus 4 plus 9. All right? And we also have been told that the horizontal line that we just graphed was y equals 5. So if we want to algebraically, and that's the important thing right now, algebraically, we are going to learn right now how to algebraically solve this equation, which basically means that we're taking this function and setting it equal to 5. Does that make sense that that's what we're doing? We're taking this function and setting it equal to 5. So the algebra behind this problem can get pretty messy. And if you are someone who makes mistakes with algebra, this is going to be hard for you. And this will be on your test when you take it. And you must know how to do this, or you will get a bad score on your test. So algebraically, step 1 would be what? We did that, set them equal. Step 1, algebraically, to solve for x. This is all about inverse operations. Subtract 9. 7 cosine of 2 pi over 13 times x minus 4 equals -4. The second step for solving this algebraically would be divide by 7. Subtract?
I was going to say distribute.
No, don't distribute a thing. All you're doing is undoing, 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 undoing. Okay? Now you get cosine of 2 pi over 13 times x minus 4 equals -4/7. What do we want to undo now? Cosine. The way that we undo cosine is with arc cosine. And the formula for arc cosine of x is plus or minus what? Inverse cosine of x plus what? 2 pi n. Why the 2 pi n, Jake? But why add something to get those coterminal angles that you were talking about earlier? Okay? 2 pi n. Did you see how many answers we were finding? It was like 6 answers. The only way to find all of them is to keep adding 2 pi, 2 pi, 2 pi, or 360. All right, so we do arc cosine. The cosine cancels, and you're left with 2 pi over 13 times the quantity x minus 4 equals. And now we go to our formula. Arc cosine of -4/7 is plus or minus inverse cosine of -4/7 plus 2 pi n. Now we use our calculator. And we ask our calculator, what's inverse cosine of -4/7? And what does our calculator give us? 2.17, 2.18. Do we agree? 2.18? 2.18 plus 2 pi n. Now, technically, what do we want to get rid of now? The 2 pi over 13. Right? This is all inverse operations. It's all algebra. How do you get rid of the 2 pi over 13? Multiply by the reciprocal 13 over 2 pi. When you multiply both sides by 13 over 2 pi, on the right-hand side, this is, Audrey, a distributive property. You have to multiply the 13 over 2 pi times the plus or minus 2.18 and the 2 pi n. On the left-hand side, it cancels the 2 pi over 13 and leaves you with x minus 4 equals. Now, nobody's going to forget to multiply the 2 pi n by 13 over 2 pi. And you're excited to do that because what happens? The 2 pi's cancel and leave you with plus what? 13n. But this is what you're going to forget to do. So on your calculator, 2.18 times it by 13 and divide it by 6.28. 2.18 times it by 13, divide it by 6.28, and what do you get? 4.15? 4.51. Okay. This is where you're going to get confused, right there. Now, the next step algebraically is to add 4. Now you have x equals 4 plus or minus 4.51 plus 13n. And here's where you separate the problem into two sides. One side is 4 plus 4.51 plus 13n. The other side is 4 minus 4.51 plus 13n. Yes?
Is it okay if we just write down negative 0.51 plus 13n?
Sure. Just when in doubt, showing lots of work. If you do make a careless mistake, the more work you've shown makes it easier for me to figure out, is it a little mistake or a big mistake? Now, when n is 0, x equals 8.51. If you remember looking at the graph of this problem that we did earlier, we approximated a spot right there as 8.5. Remember? We want to find 1, 2, 3, 4, 5, 6 answers right now. So we just found 8.51. Would it make sense on this one to go down?
Yes.
Yes. So on your calculator, 8.51 minus 13, and you get negative 4.49. That very first solution that we found was negative 4.5. Remember? There it is, negative 4.49. Now, go back to the 8.51 and make n 1. So now add a 13. And what do you get? 21.51. When we estimated our solutions, one of them was 21.5. Okay? Do we need to find any more on this side? No. Now it's time to go over here and do this side. Can you see why it benefits you to be really neat and clear? Okay? So, when n is 0, x equals what? Negative 0.51. Remember, we found that solution graphically, negative 0.5. There it is. Do we need to go down? No. Negative 4.5 was the only one we needed to find. Now we need to go up. Yes?
Wait, I'm sorry. I don't know why it's just 0.51.
Because n is 0.
Oh.
So it's negative 0.51 plus nothing. N is always 0 first. Yes?
Why didn't we need to go down for the second part?
Because we don't need a negative 13. By looking at this graph, it was negative 13 wasn't in it. Okay? So on the test that you take, you're going to see the same idea. I'm not going to ask you to come up with the equation. I'm going to give you the equation. But I'm going to have you take a sinusoid. I'm going to tell you to draw a horizontal line through it and ask you to estimate the solutions. And then I'm going to ask you to solve it algebraically. And solving it algebraically is not so much fun. Okay? But it's the beginning of solving equations. And it's super important. So, we're going to make n1. We're going to take negative 0.51 and add 13, and we get 12.49. If you remember back to our problem, we estimated at 12.5, and 12.5 and 12.49 are pretty close. We're going to make n 2. And we get what? 25.49. And if you look at this graph, we estimated our last one at 25.5. So we found all 6 of the ones that we found graphically. Now we just proved it algebraically. Now, that's what algebraically looks like. A big part of this class is understanding that there's a graphical answer, an algebraic answer, and even a numeric answer. A graphical answer we just did. We looked at where the sinusoid and the horizontal line intersected, and that was our graphical answer. Algebraic is that long, arduous, pain-in-the-butt procedure. If you did need to do numerically means plug the number in. So let's say you wanted to prove 8.51 numerically. It would mean go back to the original problem, plug in 8.51 as x, subtract 4, multiply it by 2 pi over 13, take cosine of it, multiply it by 7, add 9, and you should get 5. All right. Thank you for staying after the bell. Red button?
Yes.
Okay.